we're going to look at graphing some hyperbolas. Now, one thing I have got working on is my formula sheet for my hyperbola. So I'm looking at that. We're going to be identifying vertices, foci, and the asymptotes. I'm going to be relying heavily, especially at the beginning, to identify all the different elements from my formula and how those can be used with my formula sheet on the side here. First things first, we're going to identify all the parts. Number one, we need to know what A is, what B is, what C is, and then the center, HK, is going to be important as well. In this example, one of the things you're going to realize when you're looking at the formula sheet that the first value is always A squared and the second value is always B squared. This is going to be one of those things where this is different from the ellipse. The center is the same as it was before, right? So this one's the easy part. It's going to be -2, 0. A, obviously, A squared is the beginning, so A is 3, B is 2. A few other things that are different here, if you're looking at your formula sheet, in the hyperbola, we also know that we have A squared plus B squared equals C squared. This is the Pythagorean theorem. In the ellipse, it wasn't the same way. One of the things that I always remember is the sign here and the sign there are backwards. They never match. Even in the ellipse, they were always opposites. So I'm going to go ahead and find C. So we're going to have 9 plus 4 equals 13. So C is going to be the square root of 13. I'm just going to leave it at that point for right now. The goal of this problem is to graph it. I don't need to list all the parts down just yet. We're going to go ahead and sketch the graph and then come back and we'll get our asymptotes and our foci. So the center is -2, 0. So we're going to go over -2 and 0. So we're going to have a center located here. The foundation of creating your hyperbola is to create the box that we use our asymptotes to kind of draw through the diagonals. So I'm going to use, first of all, I'm looking at my A squared is always up front, right? So the question is, what variable is above A squared, right? This is the variable that connects the vertices. A always, no matter how you're looking at it, A always connects the vertices. B, in the ellipse, it connected the covertices. In the hyperbola, these points don't have names, technically. I mean, we don't call them covertices. If you wanted to say that, you could, but they're not technically on the actual shape. But they are going to help us to draw the box. So we know that since X is up front, we're going to have a horizontal transverse axis. So the graph is going to kind of have this shape. My transverse axis is the axis that's going to be connecting my two vertices of this shape. It's kind of like an inverted ellipse. It's kind of an ellipse that goes out instead of connecting inside. And so I'm going to use A. A's 3, so we're going to go back 3 steps. We're going to go 1, 2, 3 to get this value, and 1, 2, 3 to get this value. Now, if I'm being careful, I'm going to go ahead and write down my vertices. Right? So vertex 1 is going to be 1, 0, and the other one is going to be -5, 0. All right, done. That's an easy one. I'm going to take B. I'm going to go up and down with it, right? 1, 2, and down 2. So at this point, it feels like we're graphing an ellipse, right? But here's what's going to happen. You've just mapped out essentially the midpoints of all the boxes, right? So I'm going to draw vertical and horizontal lines through my dots, and it'll create this rectangle, possibly a square. And what I'm going to do next is I'm going to draw a diagonal line from the center, kind of just out through the corners of the box. Right? It's a lot easier if you start from the center and just kind of connect the box's corner to the center rather than trying to make this entire straight diagonal line. Okay? We know that so what I've just drawn are the asymptotes, and I'll get to how to find those formulas in just a minute. But I want to go ahead, I want to draw in the actual hyperbola shape. I'm going to start at the vertex. I'm going to go up the sides, but I'm going to stay within the asymptotes. All right, so there's one side, and there's this side here. So these are horizontally away from each other because x is on top. If y had been on top, like number 3, then the graphs would have been vertical. They would be going up and down. Okay? The other things we have to do here is we need to find our formulas for the foci. All right? So if we talk about the focus, or each of the foci, we know that they're going to go out the square root of 13. The square root of 13 is, let's just say it's 3 point something. Let's say, what is the square root of 13? It is 3.6, right? So approximately 3.6. So I'm going to go out 1, 2, 3, and then a little bit more. And so I'm going to get my focus there and go out a little bit more and get my focus here, right? So we have our focus and our focus. Now notice these occur, just like the parabola, they occur inside the shape, inside that curved surface. If you get a focus that's in the box area, you've gotten it wrong. In this example, something is different, is that C is greater than A. In the other examples, in the hyperbola, A was larger. In this example, A and B don't really have a particular relationship. They can be the same. B can be larger, A can be larger. But what we do know is that I have to add A squared and B squared together to get C squared. So that means that C is always going to be the biggest one. So I know that I took my center, if I'm looking at my formula sheet, to get the foci for the horizontal transverse axis, the formula is H plus or minus C, comma, K. So we're going to I'm going to do that, but because I had a radical, I'm going to use the square root of 13. H is negative 2 plus and minus the square root of 13, comma, K, which was 0. I can separate them, or I can leave them together with the plus and the minus there, as you see. Or I could leave them. I like to leave them together. If it's multiple choice, I know that I'm going to be looking for those two things, and sometimes they put them together like that too. The last part is to find the asymptotes. I'm going to pull up the formulas for the asymptotes because it's just a lot easier to do it that way. My formula for this one is y equals k plus and minus b over a times x minus h. And so I started off this problem by doing all of the pieces, right? A, B, and H, and K. So I really already have all this stuff. So it's going to be y equals K, which is, in this case, 0, plus and minus B over A. B is 2 over 3, and then it's X minus A negative 2. And so I can separate these. These are typically written, they're two different lines. So 2/3 X plus 2. I could multiply that out, and we're going to get y equals 2/3 X plus 4/3 is 1. The other side of that was going to be negative 2/3 X plus 2. And I'll distribute that. We're going to get y equals negative 2/3 X minus 4/3. And so I would get two asymptotes that look like this. It's really a matter of me just plugging in my little formulas, the ones we have right here, and then just kind of plugging everything in and then simplifying it, distributing this piece here, and connecting all my like terms. In this case, I didn't really have any like terms with the 0 involved, but if I had, I would have taken this whole number and I would have added it to the 4/3 or whatever it happened to have been. Okay, so that brings us to the end of number 1. It allows me to go left and right. I found A, B, C, H, and K to start with, and used my formulas to kind of build the elements in that way. So we ended up getting all our solutions. Our vertices ended up being here. My foci are here, and of course my asymptotes in the graph are there. Let's try number 2. Okay, this one, I'm going to go ahead and write this in. A is going to be 1. Well, here again, we have x over the a squared, and so that means my graph is going to be going left and right. Major axis is this way. This is called, sorry, not major, this is called the transverse. They don't call it the major axis because it's not always the longest. Transverse axis connects vertices. The other axis, the one that's going to go up and down here to create your box, is called the conjugate axis. Not a big deal that you remember those, but sometimes I need to know that A is going to go with transverse and B is going to go with conjugate. Those are the things I want to make sure I do remember. Let's write it all out. Okay, A in this problem is going to be 1. B is going to be, so B squared is 16, so B is 4. That means that C is going to be the square root of 5. We know that our center is going to be 2, 0. Let's go ahead and graph some of this. It's definitely an easier task to graph this as you come to them, right? So going over one there and there. Since I used A to find that, remember A is underneath X, so I went left and right like the X-axis. My vertices are going to be 1, 0, and 3, 0. I'm going to go up. This time I'm going to go up 4, so 1, 2, 3, 4 here, and down 1, 2, 3, 4 here. I always make this box a dotted line, just like the asymptotes are dotted. Dotted is implying that the graph, the pieces that I'm drawing, technically are not part of the graph. The graph should be a solid line to indicate that it's part of your answer. Oh, that was a terrible line. I wanted to curve that back a little bit. There's that. And here's this one. Really, God, what is my problem? I don't like how steep it is. So we end up getting it this way. Be really clear. This graph is going to be opening left and right because X is first. And so I'm going to be careful to do it that way. One of the biggest things that people miss on these kind of problems is opening the graph the wrong direction. That's usually one of the easiest things to determine. Since X is first, the graph is going to be opening left and right. If Y was first, it's going to be opening up and down. We'll see that in just a minute. Okay, so I've got to put my foci in. I'm going to go ahead and plot those. Here we have, it's the same as before. We're going to take my center, right? That's going to be 2 plus and minus the square root of 5, comma 0. The square root of 5 is just a little bit over 2, so you're going to go, let's see, let's calculate that exactly. So the square root of 5 is 2 which is approximately 2.2. So I'm going to go up 1, 2, and a little more. So we have our first focus here. Go back 1, 2, and a little bit more here, and have our other focus there. The farther your focus is away from the curve, the wider it's going to be. The closer it is to the vertex, the taller and skinnier it's going to be. And so we have, the graph is done. Let's write out my asymptotes. I'm going to pull up the formula, same formula as we used last time. So it's going to be y equals, let's see, k, which in this case is still 0, plus and minus b over a, 4 over 1, times x minus the center point of 2, x minus h. Okay, so I'm going to distribute this again. This will be a really nice one. We won't have a whole lot of fractions. So it's going to be y equals 4x minus 8. And if I look up here, and my graph's drawn not super accurate, but I can tell that that line definitely was going to go through right about 8. I'm expecting this one to probably do the same thing, although that one you can tell should have been a little bit lower. Okay, y equals negative 4x plus 8. Right? So we can see those two values here. We had one up positive 8 and one down at negative 8, or almost should have been down at negative 8. I'm not so concerned that your graph kind of is off a little bit like this, but what I do concern myself with is the points here are accurate. And for any other kind of issues, I'm going to look at your actual values that you have set up over here. That's what's going to be really important, right? So you have your focus, your vertices, your foci, and then your two asymptotes, or the parts you're going to be writing down. Okay, so that's 1 and 2. 3, we finally get to do a little bit of a different graph. 3 is one that's going to be going up and down. So we are going to do this again. Y is first. That means the graph is going to be opening up and down like this. A is still 4. B is still 5. So that's not changing anything, right? We've got to add these together. C is going to be equal to 16 plus 25 is 41. So we're going to have the square root of 41, which is approximately, square root of 41 is 6.4. I do this to get the decimal just so that I can really be able to understand how far I'm going to be going to graph this. Writing the coordinates, I'm definitely going to stick with the radical, but I'm going to graph it. I need to know about how far it is away from the center. So this really helps out. By the way, the center, that's just going to be, this is an easy one. It's 0, 0. Remember, H still comes from the X and K still comes from the Y. So when those are switched around, be careful not to get those backwards. It's real easy to get those kind of switched around. So let's go ahead and graph this. 0, 0 is going to be my center. I'm going to go up A, right? So A is underneath Y. This is always A squared in the hyperbola. This is always B squared. So since A is under the Y, we're going to go up and down A. So 1, 2, 3, 4 here. Going to go down 4. These are my vertices. Remember, A always gives you the vertices. So we have 0, 4, and 0, -4. For the foci, we'll come back to those. I'm going to use B. B's 5. 1, 2, 3, 4, 5 here and here. Notice I haven't been writing down those coordinates because they're not really important. They allow me to get the graph correct, but they're not part of the graph. They're a scale so that I can get these asymptotes done correctly. I'm going to draw the asymptotes now so I can get the scale and the curvature right. Remember, these are going up and down. Y squared is first. Always double check that. It's super easy to get wrong, but it's also really easy to know which way to go. Should it ever be a question in your mind about that? All right, I'm going to draw in my asymptote or my foci now. I'm going to go up 6.4 and down 6.4 from the center. So we're going to go up to 6 and a little bit, about halfway, I guess. I'm going to go down 6.4 as well. So we have our focus 1, our focus 2. I always write F in there just to kind of make sure that it's visible. I can see what I'm doing. So the focus here, this is going to be a different one. I'm going to pull up the formula for the foci on this one. It's H, comma, K plus and minus C to get this one because this is now a vertical transverse axis, right? My transverse axis is the axis that connects the two vertices, right? This is vertex 1 and a vertex 2. So if I write this down, the center is 0. And it's obviously it would be K plus or minus C. Since K is 0, I'm not going to use 0 plus or minus. I'm just going to use plus or minus C. So plus or minus the square root of 41. My asymptotes, if I write the formula for this one, remember this is the vertical transverse axis. It's y equals K plus or minus, this time it's A over B. If I do it this way, it just swaps the A and the B, and everything else stays the same. One of my major concerns for this problem, or this particular scenario, is the fact that there's a lot of similarities here, especially within the hyperbola and then connecting that back to the ellipse. If you've got your formula sheet down, you're going really carefully, it shouldn't be a big deal. Fill this all in. So K is 0 plus or minus A over B, so 4 over 5 times X minus 0. So real quickly, this turns out to be really easy. It's going to be y equals plus or minus 4/5 x. So there's nothing to add or subtract there, so I'm just going to kind of leave those all together. Otherwise, you do get some different values for your y-intercepts. All right, so you can see the different results for number 3. Let's look at the last one, number 4. I'm going to kind of run through this one a little quicker. This is back to a horizontal transverse axis, right, because x is first. A is 2, B is 2, C is the square root of 8, which is approximately, it's going to be 2 square roots of 2, which is 2.8. Okay, my center, this is going to be -3, 0. So -3, 0 is here. I'm going to go left and right, 1, 2, 1, 2, up 2 and down 2 to create this. This one's going to be a square because A and B are exactly the same size. Let's write my vertices out. I'm going to have -1, 0 and -5, 0. Asymptotes go like this. The graph is going to go like this. Got to get my foci in there. There we go. Foci is 2.8, so I'm going to go out 1, 2, and 8.8 here. I'm going to go back and 8 there. So in this case, it's going to be -3 plus or minus 2 square roots of 2, 0 are my foci. The asymptotes, y equals k plus or minus b over a times x minus h. Plug all this stuff in. Y equals, let's see, k0 plus and minus b is 2 over 2 times x minus h, which is going to be -3. So we end up getting y equals 1, well, let's just say x plus 3. And we get y equals -x minus 3 are the two asymptotes. And that brings us to the end of this assignment. Okay, so take a minute. Those things take a little bit of time to get used to. If you're good at the ellipse, then that's going to come in definite help. And that makes it a positive thing to get this done. And hopefully you can make those minor adjustments and figure out how they're done. If you have any questions, please feel free to email me, and we will take care of it. Have a great day.